All right, so these next types of problems are tricky because they're not asking for the molarity. They're asking you for either mass or volume. And so we have to kind of work backwards in a way and use our molarity to help us out. So molarity is going to become just a little bit different for us. Molarity is actually going to be used as a conversion factor. So what I'm going to do is I'm going to set up my problem. We were given liters, and we are trying to find the mass, which comes from moles. So our goal is to take our liters and convert it into moles using our molarity here. So I'm going to show you guys the long way, or the shortcut way, and then I'll show you guys kind of how I derive this information. So the shortcut way is to take our 2.5 liters, are given, and we're going to use our line method here. So this is what we were given, and we're going to use our molarity to convert to the mass. So I'm going to take my 2.5 or 2.0 m, which we know is 2.0 moles per liter. So we're going to put that 2.0 moles on top so that I can put 1 liter on the bottom. I did that on purpose so that my liters would cancel. Okay, that gets us to moles. Is moles what we wanted? Find the moles? No, we want to find mass. So can we get from mass, or moles to mass, moles to grams? So for this one, we used our molarity in this conversion factor. And in the next one, we're going to use molar mass. So right here, we're going to use molar mass. Okay, so our molar mass, we're going to put moles on the bottom and grams on top, so grams per mole. So we need to find the molar mass for this substance, calcium bromide. So let's take a look at the periodic table. All right, so to find the molar mass, we add the atomic mass for all atoms, and we're looking at calcium bromide. So for calcium, we're going to use this number 40.08, and we're going to add it to bromine, which if we look over on this side is 77.9. So 77, or sorry, not 77, 79.9. Oh, all right. So the problem is that I actually have 2 of these, so I could either add this number again, like this, or I could do something like this and add it to 2 times 79.90. Either method work. I prefer this one, so I'm going to plug this one into my calculator to find the molar mass. So we're going to take 40.08 and add it, because we're adding the atomic masses, add it to parentheses 2 times 79.90, close parentheses. So the only time I can times is when I have multiple atoms of the same atomic mass. Our answer is 199.88 grams per mole. So I'm going to put that 199.88 grams here per 1 mole. And now we're ready to do the math. You'll notice that moles will cancel, and you're left with grams, which is what we were trying to find. So we'll go ahead and plug this into our calculator. 2.5 times 2 times 199.88. Enter. And then I'll divide it by 1 times 1. And I'm going to use my parentheses like that so that we get order of operations. But we're timesing by 1, so it really doesn't matter here. Your answer is going to be 999.4 grams of calcium bromide. Okay, so that's our answer. We can go about this a different way, and I'll kind of show you just a setup real quick. And some people like this method. So what you do is you take your 2m and you turn it into a word problem. So, or we turn it into the equation. So we'll say that 2m is the same thing as 2 moles per liter. So if we have big M equals moles per liter, we're given this number, and we're given this number, but we don't know what moles is. So we would say 2.5, 2m equals x over 2.5 liters. So we would just solve for x. So you guys probably know how to solve for x, so times by 2.5 liters on both sides. And to times 2 by 2.5 should give you 5. So we have 5 for our answer of moles. And then to complete this problem, we're just going to use the same conversion we did up here. So I'm running out of room a little bit, but we're going to use 1 mole on the bottom and that same molar mass. And if I use this correctly, I'll just plug this into my calculator, and we'll take 5 times 199.88 and divide by 1, and you should get the same answer. If you don't, something went wrong. Okay, the next type of problem, I'm still going to use molarity as a factor. I'm going to do the shortcut method, which I think is easier, but you guys can do either method. Okay, so what is the volume of 3 molarity solution of NaCl made with 15.6 grams of NaCl? So we need to come in here and look and make sure we know what's going on. We were given 0.3 big M for molarity, and we were given grams. So what I'm going to do is I'm going to take what I'm given first. This is going to be considered a conversion factor. So let's start with 15.6 grams. And again, we're going to use the molar mass to get this answer. So you use molar mass. Now let's quickly look up the molar mass for NaCl. So if I look at the periodic table, I find that sodium is 22.99 and that chlorine over here is 35.45, and I simply add those numbers together and you should get 58.44 grams per mole. Alright, so I'm going to put that 58.44 grams down here on the bottom so that grams will cancel out, and 1 mole on top. And at this point we're at moles, which we're trying to get to something that is volume. So we're going to try and use another conversion factor. So we're going to use molarity here. And if 0.3 m is equal to 0.3 moles over 1 liter, then I can plug that into my equation. I want moles on the bottom, so I'll put 0.3 moles down here, and I'm going to put 1 liter up there. So moles cancel, and we are left with the unit we are trying to find, which is liters. So we're trying to find volume. Okay, last step is to plug this into the calculator. So you would take your 15.6 times it by 1, times it by 1, hit enter, and then we're going to divide it by the bottom row. So I'll put my parentheses so that my order of operations isn't thrown off. I'm going to do 58.44 times it by 0.3 and then close my parentheses and enter. This should be our answer. We're going to put 0.8898 liters of this stuff. Now again, I can show you guys this way, this method of doing it with more logic. So we have moles. No, we don't have moles. We have grams, which we can get to moles, and we have molarity. So we have this number. We can get to this number if we need to. And liters, we have liters when we finish the problem. So first thing you got to do is you've got to convert your 15.6 grams using this conversion, 58.44 grams. This is just the molar mass per 1 mole. And if you do that, we will find 15.6 times 1 divided by 58.44. You get 0.26694 moles. And then we can plug that number into this problem here. And we can plug our molarity into that problem. So if we put 0.3 m equals 0.267, I'm going to round there, moles over x. So this gets a little trickier, but you need to do a little bit of algebra. If I times by x and then divide by 0.3, basically these things swap. So I'll show you down here kind of what that looks like. X equals 0.267 moles over 0.3 big M. And then we just plug that into our calculator and we should get the same answer. So 0.267 divided by 0.3, and we should get 0.89 because I rounded a little bit liters. All right, last problem. So the last problem is giving you lots of numbers, and so this one is a little tricky. We're going to try and compare two molarities, so we're going to use a different equation. So the equation is M1V1 equals M2V2. So we're going to try and identify what the molarity and the volume is for one solution, and then what the molarity and volume is for another. So for the first solution, it's asking us what is the volume of 0.5, and the second solution says to make 700 milliliters of 1.0 molar solution. So I do have a lot of these things. Let's see, my M1 is 0.5 molarity. My V1 is the thing we don't know. My M2 is this second one right here, 1.0 M molarity, and then our volume 2 is 700 milliliters. Okay, so to get these problems here, I just plug them into the equation. So we're going to take 0.5 big M, and we're going to times it by what we don't know, so I'm going to use an x. And then we're going to set it equal to 1.0 big M, and times it by 700 milliliters. All right, now to finish this problem up, the last thing you need to do is solve for x. So I'm just going to divide by 0.5 m on both sides, which gives me x equals 1.0 m times 700 milliliters divided by 0.5 m. Plug that into our calculator, and we'll do 1 times 700 divided by 0.5, and we get 1400. Okay, and this is milliliters, and I'll show you why, because our molarity will cancel out there, and you're left with milliliters. If you want to, you can convert it to liters, but I don't need it to be in liters because I asked you for volume. So unless the problem specifically says in liters, then make sure you turn it to liters. So here's your answer. Let me know if you guys have any more questions on these problems. I'm willing to give you guys some conferencing or some help on the different types of problems. So let me know. Thanks.